In this example, I'm going to show you how to solve higher degree polynomial equations by factoring. And the way we're going to do this is extremely similar to solving a quadratic equation by factoring. So as you can tell by the method, the first thing we need to do is actually factor our polynomial. And then what we're going to do is rely on the zero product rule to actually solve for the variable. So in example A, you can see that I'm already set up and ready to go for factoring. The first thing you need to do is collect all terms on one side of your equation, leaving 0 behind on the other side. Then what you need to do is factor your polynomial equation. So we have 4 different methods for factoring. You can see there is no greatest common factor between all 4 terms. So what I'm going to do is factor by grouping. So I'm going to group terms together that have something in common and then factor out the greatest common factor of each group. So the greatest common factor of the first group is y squared, leaving behind y plus 1, and the greatest common factor of the second group is -4, leaving behind y plus 1. And then you can see the greatest common factor of this term and this term is y plus 1. So when I factor that out, I'm left with y squared minus 4. And then I can see that this right here is a difference of squares. So I'm going to factor this factor. So that difference of squares will factor into y minus 2 times y plus 2. And I have now factored this polynomial as much as I possibly can, and this product here is equal to 0. So using the zero product rule, I will set each factor equal to 0 separately and solve each of these linear equations. And so this equation right here has 3 solutions. They are -1, +2, and -2. And as always, you can check your answer by substituting the value back in for your variable and confirming that you get a true statement. So what we're going to do is apply the same technique over here in part B. So I'm going to collect all my terms on one side of the equation, leaving 0 on the other side. Then I'm going to factor this polynomial. This is a difference of squares. So I'm going to factor this difference of squares, giving me x squared minus 3 times x squared plus 3. This right here is actually another difference of squares. In fact, if I rewrite that factor, it is x squared minus the square root of 3 squared, and I can factor that. And I have now factored this as much as possible. This product here is equal to 0, so I'll use the zero product rule and set each factor equal to 0 and solve each of those equations. So I get 2 very nice real solutions right here. And then with this equation, I get a non-real solution. In fact, 2 non-real solutions. So I have the square root of -3 and the negative square root of -3. Remember that an even root of a negative number is not a real value. So this would be square root of 3i and negative square root of 3i. And these would be your non-real solutions. And these 2 are your real solutions. Okay, so when you're solving a polynomial equation, by factoring. What you want to do is collect all terms on one side of the equation, leaving 0 on the other. Then you want to factor that polynomial using an appropriate method. Factoring by grouping, factoring out a GCF, factoring a difference of squares, factoring a trinomial, etc. Once you have completely factored your polynomial, you want to use the zero product rule by setting each factor equal to 0. Sometimes your polynomial equation will yield non-real solutions, and sometimes they'll all be real.